Okay, let's talk about this. And I know I've been hitting you with tests pretty frequently. There's going to be one later this week, and here's kind of what you can expect. There are going to be some problems at the end of the packet to do, but and don't go ahead till I say in this video to go ahead and, if you feel confident, go ahead and work ahead. Now, these are easy to solve. You don't need the boxes, okay? All you have is 3 to the 4th power. So I clone the 3 4 different times and then find the product. So 3 times 3 times 3 times 3, and I get 81. Okay. It's pretty much just a standard answer to these first page problems here. Now I'm going to clone a -3 out 6 times. 6 of them. So I take -3 times -3 times -3 times -3 times -3 times -3. That's positive 729. Now you're like, well, how do you get a positive out of that? Because there are 6 negatives. There's an even number of negatives, and these cancel out, these cancel out, these cancel out, and that's how that ends up like it does. -2 to the 3rd, I clone the -2 3 times. So I take -2 times -2 times -2. That gives me -8. Okay, now the reason we have a negative here and not here is because there's an odd number of negative factors. Okay, here I have, these cancel out, but then what about this one? So that's why that product has a negative on the answer. Now, you don't get freaked out about the fraction, okay? What you do is write 1/7 times 1/7 times 1/7 times 1/7. So you clone the fraction. Then I multiply the 1s and I multiply the 4s. So clone the fraction 4 times, multiply, but you're multiplying just the 1s on top, which is 1. If I multiply any amount of 1s, the product is 1. Then I go 7 times 7 times 7 times 7. That's 2,401. 1 over it, though. Okay, now on the next page, now they start throwing variables at me. And also, a lot of times there's more than one exponent. Okay, here we just had 1. So that's why I'm going to use the boxes to simplify. It's a little bit more complex. Now remember, the first procedure, we need to make our dividing line, and then I'm going to circle my parentheses, so I have one here and here. So on top of the line, I have a number 2 and a number 7. We want to put those multiplied by each other, and the only variable I really have is x, the only letter. Okay, so let's talk about the 2. The 2 is to the 1 power, but it's in that circle, so I need to take 1 times 3. And that's 3, 2 to the 3rd. Now the 7's in a circle, that's a 1, and I take 1 times 2, and that's 2. Okay, now for x, I have 2 different x variables, so here's my first one. Now it's to the 5th, but it's in a parentheses, so I need to take 5 times 3, and 5 times 3 is 15. And now the other x is still on top of the line. Okay, when I look at the dividing line I made, there's nothing under it. The other x is on top, so that would be an addition. Okay, and then I take 7 times 2. 7 times 2 is 14. And then I take 15 plus 14, and that gives me a sum of 29. Okay, now circle your all of your factors. 2 to the 3rd, 7 to the 2nd, x to 29th. Well, that's positive, that'll stay. The 2's positive, that'll stay. The 29's positive, that'll stay. So everything's going to stay in the same place it's at. So 2 to the 3rd times 7 to the 2nd times x to the 29th. Okay, now we clone what we can. 2 to the 3rd can be cloned. 2 times 2 times 2, that is a product of 8, so that turns into 8. And then 7 to the 2nd can also be cloned. 7 times 7 is 49, product of 49. and then the variable stays the same. That stays x to the 29th power. Okay, that's a 29 I just wrote down, 29. Okay, now we need to multiply those two factors, the 8 and the 49. The other factor is a variable, so I don't worry about it. So 8 times 49 is 392. So the simplified answer is 392 multiplied by x to the 29th power. Okay, now here's my first one. I don't have any parentheses, and I already have my dividing line. Now I have a number 4 on top. Now on bottom I have a number 4, but I already wrote that on top. And I have another number 4, which I've already wrote on top. So really we're just going to have one single factor. So I have a 3. You don't need to multiply. There's no parentheses. So you have a 3. And then here's my next 4. Now that's on bottom, so that's minus 2. Here's another 4, but it's also on bottom, so that'll be minus 5. So I take 3 minus 2, that's 1, but then when I minus 5, it goes into the negatives, and I get a negative 4 right there. Okay, so this is my only factor, but since it has a negative exponent, it has to go to the opposite side of the dividing line. So what's the opposite of top? Well, the bottom. And then the negative 4 is going to turn into a 4. That's why we move. That is the point of moving it to the opposite side, is so we can make the negative power into a positive power. And then I need to fill the top up with a 1. Okay, so we got 1. Then 4 to the 4th would be 4 cloned 4 times over. And that's 256, okay? 1 over 256. All right, now the next problem. Now you see two different dividing lines, and in multiplication you just connect them, okay? And here's the only parentheses, so circle it and include that 7 in the circle. Now you got to pay attention here. On top of our line we have a number 3 and a letter X. Now under the dividing line we have a number 4 and a letter B. So that's all my factors. So 3's to the 1, but given the fact that that was not in the circle, I just put a 1 down. Now let's look at now let's do 4. Okay, I like to do my number factors first. Now 4 is to the 1, and again, I did not make a circle around that, so I write 1 down here. Okay, now let's talk about X. We have an X on top and X on bottom. Okay, so here's my first X, a 3, but since that's in the circle, we have to take 3 times 7, and that's 21. Okay, and then my other X is on bottom, so I will minus. And what I'm going to minus is just 10 because that was not in the circle. So it's 21 minus 10, and 21 minus 10 is 11. So the X is to the 11th power. Now let's talk about our B. Now the B is to the 1. That was in the circle, so you got to take 1 times 7, and that's 7. Okay, so I circle all my factors. That's positive, so stay. That's positive, so stay. This is positive, so stay. And this is positive, so stay. Okay, everything's staying. So keep everything in the same place that it's already at. Okay, you don't move anything to the opposite side of the line. You just keep everything like it is. And then you don't really clone anything. If it's just a 1 power, that becomes a 3. Then the variable and its power, and then 4 to the 1 is 4, and B to the 7th. Now I don't, like up here I did 8 times 49, but here I'm not going to do any operations with 3 and 4, okay, because they're on opposite sides of the dividing line. Don't divide 3 by 4 because it's a decimal. See, if you get a decimal, don't do it. Okay, next problem, make your dividing line. And circle the only parentheses you have with that 3 outside. So on top of your dividing line, you have a number 3, you have a letter X, and you have a letter Y. That's all the factors. So 3 is to the 1 power. So I multiply, that's in the circle, so it's a power to a power. I take 1 times 3, and that's 3. Now for x's, there are 2 of them. Let's take this one first. Now since that's in the bubble, I need to multiply the -2 times 3. All 3 belongs to everything in here. So it can't go, I have to multiply. -2 times 3 is -6. Then my other x is on top, so that would be plus 5. So -6 plus 5 is -1. Then I only have one single y factor here. I take 2 times 3, and that's 6. So here are my 3 factors. That's positive, that's stay. That's negative, that's opposite. That's positive, that's stay. Okay, so the 3 to the 3rd and the y to the 6th stay where they're at on top, but this x, what's the opposite of the top? The bottom. So you move that to the bottom, -1 goes to 1. Okay, we can figure that one out. That's the only one we can simplify. Clone the 3 times, and that equals 27 for product. So 27 times y to the 6th, and then we have x to the 1. Okay. Scientific notation. You might as well write times 10 right now. Okay, here's my first decimal. That's the first thing. Now, going from the beginning, what's your first non-zero? It would be 2. So now I got to decide if I have to move that decimal. Remember, it's got to go between the 2 and the 7. This is right. This is left. Well, I think to get the decimal to here, I'd be going to the right. So that's right. So the exponent's negative. Okay. So 1, 2, 3, 4, 5, 6. So 2.7. So you go point, and then you have a 2 in front and a 7, 3 behind. Now remember, our base 10 has to have a negative power. Okay. And count the digits between the decimal where you began and where you stop. So here's what I do after this decimal. 1, don't count that. That's outside the boundary. So between here and here. So 1, 2, 3, 4, 5, 6. So 2.73 times 10 to the power of -6. And if I want to check my answer, that looks exactly what I started with. Okay. All right, now writing a number from scientific form to standard form. So I'm going to write 2.83, and or no. What am I doing? I can just do that on the calculator. 2.83 times 10 to the power of 8. Okay, that's what we have. There is no decimal here. Generally, there's not going to be when you multiply by a 10 to a positive power. That's usually when 10's to a negative power. Okay, so back from, we got comma, 283 million. Okay, now we reach at the part of the video where I don't need you necessarily to work all the examples. We're to a point in the video where if you start to get this, you can go do the last 4 in the packet, okay? You have a 1, 2, 3, and 4, okay? All right, so our first example, I'm going to do 4 of these, but you're to a point where if you get what I'm doing after watching one, you can go work. I originally make $30,000 in a year at my job. The pay increases at a rate of 5% per year. Find the new salary after 7 years. Okay, so the first thing I'm going to do is create a box. Now there are 2 units that vary, the dollars and the years. And again, the X's needs to be the years and the Y needs to be the money. So per year, and let's put dollars above that. Now let's go find there's per year, but it's 5%, okay? Now that's much different than $5, so don't construct a line because it's not going to be a linear equation. It's going to be exponential, okay? EXP, exponent. So I go blank times blank equals blank. So I have original. I have the percentage, and I have new, okay? Let's do our percentage first. So we have 100%. Now we circled the word increase because that tells me, okay, I need to add 5%. So that's 105%, and then divide it by 100. Now that's going to be 1.05, but since that was per year, that needs an exponent. And how many years do I have? Well, I have 7, so it's to the 7th power. Now, the original price is $30,000. It says it's the original, or the original amount of money I make. It's not really a price. And then X. Now, I'm gold. I just multiply. But I got to remember to put the 7th power on the 1.05. Okay, and I end up with, now if this is money right here, you need to put a money sign, and if it's money, go 2 numbers past the decimal. So 42,213.01. $42,213.01. Okay, next up. A car is originally worth $24,000. Its value decreases at a rate of 8% per year. Find the new value of the car after 5-10 years. Okay, so we got dollars and years. So again, X is the years and Y is the money. So per year, it's dollars per year. Okay, well, when I look at per year, I don't see a dollar amount. I see a percentage, so 8%. So that's not a line. Don't construct a line. That's called an exponential function, okay? So that's when I want to set this up, and that's pretty much true in story problems in algebra till, you know, you get to advanced stuff, which you might probably never take, to be honest with you. And this is my percent. That'll be to a power because it's per year. It's 8%, but it's per year. And here's our original amount, and here's our new amount. Now, again, we're going to want to apply our percent first. So I take 100%, and it decreased at a rate of 8%. So that would mean I minus 8%. Remember, I have circled the word that kind of helps you out whether to knowing whether to add or subtract. So 100 minus 8% is 92%. Okay, and then I divide by 100. And what dividing by 100 does, again, it allows me to put this into an equation and do operations with it. So it's 0.2. Now it says per year. Well, how many years do we have? Well, we have 10. Now, if you didn't know how many years you had, if that wasn't in the problem, you'd be in a lot of trouble with what you know now. And then our original amount's $24,000. That's original is like chronologically over time. And then our new amount is unknown. Okay, when the new amount's unknown, we just multiply these two factors. This factor has an exponent. 24,000 times 0.92 to the power of 10. Okay, now this is money, so if my answer is dollars, I'm going to need 2 digits after the decimal. Okay, so $10,425.32. Okay, you're talking money. Okay, our next problem. A bank originally has $4,000. It gains interest at a rate of 1% per year. Find the new value of the account after 5 years. Okay, so the units I have are dollars and years. Those are the 2 units that vary. The unit of time is my X. The other unit's my y. So per would be per year, and then dollars per year. Okay, now per year again is 1%. Okay, so because it's a percent, not a dollar, okay, that's exponential. It's an exponential function. So we want to talk about this as my original multiplied by my percent equals new. Whoops, my bad. So again, since my percent takes place per year, I need an exponent here. So let's fill in this space here. That's kind of the hardest part. So we take 100%. Now it gains interest at 1% per year, so I plus 1%. Now that gives me 101. Please divide that by 100, and that's 1.01. Now, that needs an exponent. Now it says per year. How many years we have? Well, 5. Okay. That's 4,000. That's X. Now I'm going to show this. You should keep using this key, but let's say I did this times 1.01. That's the answer after the first year. Okay. That's how much we have after the second year. I keep just repeatedly multiplying. That's how much I have after the third year. That's the fourth year. And finally, that's the fifth year. But you'll notice if I take 4,000 times 1.01 to the fifth power, I get the same thing. Now that again is money. Okay, so if it's money, go 2 digits out. Okay, 4 cents. So you got $4,204.04. Again, because I repeatedly multiply by that every year, I just use the exponent for how many years I have. Okay, then my last one. An item originally cost $250. It decreases in value at a rate of 2% per month. What is the new value after 8 months? Okay, so again, I've got 2 units, dollars and months. One of you asked me privately last week, do we ever make those, are there ever 3 units with these percent? No, not really. Okay, it's usually just 2. So X is months, Y is money. Okay, and per month. So dollars per month. So I'm looking up the per month, and I see that it is 2%. Okay. And since it's percent, not money, that's an exponential function. We don't construct the line. The only way I construct the line is that was $2 instead of 2%. The line would help me. Here it's not going to. I need a new way. So we have our new times your original equal, or not, what the heck? I'm an idiot, okay? It's the original multiplied by the percent and the new. Remember, since the percent occurs per month, we need an exponent. Okay, so I put 100%, and then it decreases, so that would be subtraction. That's 98%. So I need to divide that by 100, and that's 0.98. Okay, now that needs an exponent. Now it's per month. So I believe we have 8 months. So that multiplication happens every month. So it repeats 8 times. It's like you're cloning that procedure 8 times. So 250, and then X. Now again, to show you if I had to do it individually, I'd take 250 times 0.98. So that's how much it is after the first month. That's how much it is after, that's what it's down to after the second month. After the third month. After the fourth month. After the fifth month. After the sixth month. After the seventh month. After the 8th month. But yeah, that's probably a waste of time. I can just take 250 times 0.98 to the power of 8. Get the same thing, okay? So I get $212.69. You're talking money, so 212.69. Now I'm going to look at the problems to see if there's any. Number 1's a money, 2's a money, 3's a money, and 4's not a money, okay? You won't want to put 2 digits out. Well, I guess you could. It's pounds, so you can have decimals on pounds, I guess.